This video will walk you through how to use the quadratic formula to solve for the zeros or the x-intercepts of a quadratic function. Keep in mind that standard form of quadratics is y equals ax squared plus bx plus c. A is your coefficient on x squared and b is your coefficient on x. So even if they were not in this order, the coefficient of x is still b and the coefficient of x squared is still a. Your constant is c. The quadratic formula is x equals negative b plus or minus. So this symbol here means that you can either add or subtract the answer from the second part here, which is the square root of b squared minus 4ac, and the whole thing is over 2a. There's actually a really cute little song to help you remember this, and I'll add that video on the s'more. It kind of goes to the Pop Goes the Weasel tune. So the reason this is plus or minus is because a square root, let's say you have the square root of 25. You're looking for something times itself that could be 25. Well, we typically think of that as 5. 5 times 5 is 25. But negative 5 times negative 5 would also be 25. So technically, it is a positive or a negative 5 that would be the square root of 25. So the positive negative is kind of already built into the formula for you. And you'll kind of see how that works in a second. And then this part here that's under the radical, that's called the discriminant. And your discriminant allows you to tell if it's going to have one solution. That would be if you have the square root of 0. If it's going to have no solutions, which would be the square root of a negative number, any negative number, because there's nothing times itself that will ever be negative. That would be an imaginary solution. So if you have a negative number in your radical, there is no solution, you can stop. If you have a square root of 0, that's automatically going to be 0. And so it doesn't matter if you add or subtract 0, it's not going to do anything. So it would only have one solution. And then two solutions would be the square root of any positive number. And that's because any positive number could have both a positive or a negative solution as the square root. So what we'll do on the next few ones of these is, as we're setting up our problem, in the quadratic formula itself, we will check to see how many solutions we should get before we finish. So just like when we used factoring to solve, we need to get our equation set equal to 0. So when we have x squared minus 8x equals 9, we would want to eliminate 9 so that it is equal to 0. Now, of course, if we do something to one side, we need to do it to both. That would change the equation to x squared minus 8x minus 9 equals 0. If I had a graph, I could just graph x squared minus 8x, and then I could look at where does it equal 9 on the graph, on the y-axis. So that's possible, but it's a lot more difficult to solve that way, so it's easier to set it equal to 0. Now, we could potentially factor this, except that's not the goal of this week. We want to use the quadratic formula. So I would start by saying x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And then, thinking about standard form, I'm going to substitute a, b, and c from the equation. So a, remember, is the coefficient of x squared. This one doesn't have a coefficient, so it's an understood 1. B would be our negative 8. So we have a is 1, b is negative 8. It's the coefficient of x. And c is our negative 9. And we will substitute those into the equation. So we would have x equals negative 8 plus or minus the square root of negative 8 squared. I'm going to put that in parentheses so that it squares the negative as well. Minus 4 times 1 times negative 9, which is our c value. No. So a is 1. Mommy. And then all over 2 times a, which is 2 times 1. At this point, we would go about simplifying inside the radical and cleaning anything else up that we can. So we would have x equals negative 8 is just going to be positive 8. And then plus or minus the square root of, this would be 64 actually plus, because negative 4 times negative 9 would be positive, so plus 36. So this would be the square root of 100 over 2. Now the square root of 100 is a positive number, so we should end up with two solutions based on our discriminant. So since this part is a positive, we'll have two answers. And so what we want to do is we want to say 8, the square root of 100 is 10. So we could have 8 plus 10 over 2, or we could have 8 minus 10 over 2. So I'm going to split that plus or minus now into two different parts because I know the square root of 100 is 10. So if I have this one, 8 plus 10 divided by 2, that'd be 18 over 2, that's 9. And if I have 8 minus 10 over 2, that would be negative 2 over 2, which would be negative 1. So the solutions, or the zeros, or the x-intercepts, or the roots, however you want to think of it, they would use any of those terminologies. They would be 9, so x can either equal 9, or x could equal negative 1. Or you could write it as intercepts and say 9, 0, or negative 1, 0. So on this one, we could move the x squared and the minus 4 because we have to get it set equal to 0. But I don't ever recommend making your a value negative if you can avoid it. So instead of moving these two, I would just go ahead and subtract 2x. So I would have 0 equals x squared minus 2x minus 4. I like to go ahead and write it in that descending order of power so that it's easier to identify a, b, and c. So a is going to be 1. That's our coefficient of x squared. B would be negative 2. That's the coefficient of x. C is our constant, which would be negative 4. Then we would start with the equation for quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And you definitely want to make sure you have that written down somewhere so that you'll have it to do the assignment. Negative b would be negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 for a and negative 4 for c all over 2 times 1. And then we'll go about cleaning those parts up. So negative 2 would be 2, and then plus or minus negative 2 squared is positive 4. Negative 4 times 1 times negative 4 is positive 16. So we have 4 plus 16, so that's 20, all over 2. And since our discriminant is a positive number, that means we have two solutions. So we should be able to add and subtract the solution from this. Now this one's a little trickier than the last problem because square root of 20 is not a perfect square. So we're going to have to go back to January when we simplified radicals, and we're going to have to actually simplify the square root of 20. So let me go over here and say the square root of 20 can be 2 times 10, and 10 can be 2 times 5. So that's the square root of 2 times 5. That's something times itself. So the square root of 2 times 2 would be 2. I'll pull that 2 out. Takes care of the pair. And then that makes it 2 square root of 5. So now I can rewrite this as 2 plus or minus 2 square root of 5 over 2. And then if your coefficient of your radical and your b value are divisible by the denominator, you can distribute it out. So I could distribute the division and say 2 divided by 2 plus or minus 2 square root of 5 divided by 2. So I'm distributing that dividing of 2 out. And then I would simplify the parts. So 2 divided by 2 would be 1. And then 2 divided by 2 here would also be 1, leaving just the square root of 5. So this would be 1 plus or minus the square root of 5. And since that's an irrational number, it's more precise to leave it as a radical. So I would leave it like this. That would be our two zeros. So we would have one where One of our x's is equal to 1 plus the square root of 5, and the other x is equal to 1 minus the square root of 5. So you could split it and do 1 plus 1 subtraction, or you can just leave it as plus or minus. So honestly, I would take it split, or I would take it like this. But you do need to recognize that this form here does still mean that one is addition and one is subtraction. Okay, so for this one, we're already set equal to 0. That saves us a little bit of work. We would just need to start with the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then our a value here is 4, our b value is 4, and our c value is 1. So we would have x equals negative 4 plus or minus 4 squared minus 4 times 1 all over 2 times 4. And then we would simplify our parts. Plus or minus the square root of, this is 16 minus 16, so that's actually 0 over 8. So because our discriminant is 0, this one will only have one solution. The square root of 0 is 0. So we only will end up with one answer here. We'll have negative 4 over 8. So this solution would be negative 1/2. That's our x value. So we could either say x equals negative 1/2, or we could say negative 1/2, 0, if you want to write it as an ordered pair. You could say negative 0.5. I tend to stay away from decimals. Fractions are more precise. This one wouldn't matter since it's a terminating decimal, but repeating decimals, you definitely want to stick with a fraction. But again, this only has one solution because the discriminant was 0. So you could add 0 or you could subtract 0. You're still only going to get negative 1/5. That means that this one has its vertex on the axis. It's the only point that it touches the axis. Okay, so here's another one that's already set equal to 0. So we would go ahead and say our a value is 1, our b value is negative 1, the coefficient of x, and our c value is 3. And then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I do really recommend watching the video with the song. You don't want to hear me sing, but it does help you remember this formula. So we're going to say x equals negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times 3, just plugging in here, all over 2 times 1. And then we end up with 1 plus or minus. This is 1 minus 12. 4 times 1 times 3 is 12. So 1 minus 12 is negative 11 all over 2. We can stop because this value is negative, and there's nothing times a negative that will ever come out of that radical. And so that means that this is one of those graphs that has no solution. It either starts above and opens up, or it starts below and opens down. This one actually must be above and opens up because a is positive. So it opens up. We can tell that. That means if I were to graph this, it would look something like this, possibly, where your vertex is above the x-axis and it is opening up, so it never crosses the x-axis. It has no point where it equals 0. So this would be a great point to try this one on your own before watching the video. But I'm going to go ahead and get this sucker set equal to 0, so I'm going to subtract the 8x, and that would make 2x squared minus 8x plus 7 equals 0. And then I'm going to identify my a, which is 2, my b, which is negative 8, and my c, which is 7. Honestly, if I was doing this on my own, I may not write that out. I would probably just know those values, but I'm doing this so you can see where they're coming from. And then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to go ahead and substitute my values in. So we would have x equals negative 8 plus or minus the square root of negative 8 squared minus 4 times 2 times 7 all over 2 times 2. And then because I write way too big, let's just go up here and say that's 8. X equals 8 plus or minus Inside the radical, we have negative 8 squared, that's 64, minus 4 times 2 times 7, that's 56. So 64 minus 56 is 8, all over 2 times 2 is 4. This is another example where 8 is not a perfect square. So we would have to simplify the square root of 8. So the square root of 8 can break into 2 times 4, and 4 is 2 times 2. So we have 2 times 2 times 2. We do have something times itself, so we would have 2 square root of 2. So I would come back and say 8 plus or minus 2 square root of 2 all over 4. 8 and the coefficient of 2 here are both they can be simplified at least by the 4. So we would split this and say, distribute out your division, 8 over 4 plus or minus 2 square root of 2 over 4. And that would be 2 plus or minus, this would simplify to 1/2 here. So we would have the square root of 2 over 2. And then I would just leave it as plus or minus, but you could write it as 2 plus the square root of 2 over 2, or 2 minus the square root of 2 over 2. It's both of those answers. But again, I would just leave it as the one that keeps it as plus or minus. Now, some people may leave the 8 over 4, I guess I should show you this. Some people might say, well, this really, we should leave it as one fraction instead of 2 parts here. So they may say instead of going to 2, they may say that this could be 4 over 2 plus or minus the square root of 2 over 2. And then that way they can say, put it back together and say 4 plus or minus the square root of 2 all over 2. So they make it back into one fraction instead of 2. I personally like to go ahead and simplify both parts, so this would be my preferred choice, is to just say 2 plus or minus the square root of 2 over 2. Alright, so on this one, already set equal to 0. I can see my A is 4, my B is 1, because there's a coefficient of 1 there, understood, and C is negative 4. So we would say x equals negative B plus or minus the square root of B squared minus 4AC all over 2A. And then it would be negative 1 plus or minus 1 squared minus 4 times negative 4. It's a lot of 4s. So 4 for the A, negative 4 for C, all over 2 times 4. And then x would equal negative 1 plus or minus the square root of, that's 1, and then negative would be plus. So that would be 1 plus 64, which would make 65 inside the radical, all over 8. And then 65 is definitely not a perfect square, because 64 is, this one away. So if I said the square root of 65, that could be 5 times 13. Those are both prime. This one doesn't simplify at all. There's nothing we can even pull out of the 65. So this is our final answer, negative 1 plus or minus the square root of 65 all over 8. Or you could say negative 1 plus the square root of 65 over 8, and negative 1 minus the square root of 65 all over 8. One thing that might help you when you're going to your assignment and trying to type in an answer like this is to understand that you would need to type the numerator in parentheses, and then, so if you type in negative 1 plus or minus the square root of 65, and then close that parenthesis, then do the division sign over 8, because it's a grouping symbol, really. But if you do that as math on GoFormative, it will put that underneath the whole top, and it would write it like this. So that's how I would recommend typing it in on GoFormative.